If zero point 0.5 mole of a reaction with an enthalpy change of minus 120 kilojoules per mole occurs at constant pressure, what is the value of Q for the surroundings? Positive 60 kilojoules, negative 60 kilojoules, positive 120 kilojoules, or negative 120 kilojoules. The answer is positive 60 kilojoules. Because if the reaction has an enthalpy change of minus 120 kilojoules per mole, that means half a mole's worth of reaction will have an enthalpy change of minus 60 kilojoules. And negative 60 kilojoules means energy is flowing out into the surroundings, so the surroundings will increase by this amount of energy, so positive 60 kilojoules. Which statement correctly describes an endothermic process? Energy is transferred from the system to the surroundings. Energy is transferred from the surroundings to the system. The temperature of the system must increase, or the reaction must be chemical. The answer is energy is transferred from the surroundings to the system. Because an endothermic process has a positive enthalpy change, meaning the energy of the system increases, and that energy must come from its surroundings. Which equation is used to calculate the amount of heat transferred during a temperature change? Q equals mc delta T, Q equals m divided by c delta T, Q equals delta T divided by m times c, or Q equals mc divided by delta T. The answer is Q equals mc delta T, where Q is heat energy transferred, m is the mass of the object heat is being transferred into, c is the specific heat capacity of the object, and delta T is its change in temperature. Why does breaking a chemical bond require energy? Energy is required to overcome attractive forces between bonded atoms. Atoms must gain mass before separating. New bonds are formed simultaneously, or because energy is released as atoms move apart. The answer is energy is required to overcome attractive forces between bonded atoms. Which situation best illustrates an endothermic process? Water freezing in a freezer, steam condensing on a surface, a hot pack releasing heat, or ice melting at room temperature. The answer is ice melting at room temperature, because in order for the ice to melt, it has to absorb energy from the surroundings, meaning its energy goes up, a positive energy change, an endothermic process. Which statement best describes heat transfer? The movement of particles from one object to another, the transfer of energy due to temperature difference, the increase in temperature of a substance, or the conversion of energy into work. The answer is the transfer of energy due to temperature difference, with temperature being a measure of the average kinetic energy of particles within an object. An energy diagram shows the products at a higher energy level than the reactants. What must be true? Energy is released to the surroundings, the process is exothermic, energy is absorbed by the system, or the process occurs instantaneously. The answer is energy is absorbed by the system, because if the products are at a higher energy level than the reactants, the process is endothermic, a positive energy change, with energy going into the system. The enthalpy change for the reaction 2A goes to form B is minus 120 kilojoules. What is the enthalpy change for the reaction 2B goes to form 4A? Positive 240 kilojoules, minus 240 kilojoules, positive 120 kilojoules, or minus 120 kilojoules. The answer is positive 240 kilojoules. Because if 2A going to form B is minus 120 kilojoules, then the reverse direction of B going to form 2A would be positive 120 kilojoules. And in the reaction given, it is 2b going to form 4a, so that is 2 times the moles in the first reaction. So 2 times positive 120 gives positive 240. Which situation would be best represented by an energy diagram? Measuring the rate of a reaction, determining the equilibrium constant, comparing the energies before and after a phase change, or tracking concentration changes during a reaction. The answer is comparing the energies before and after a phase change, because energy level diagrams are used to show relative energy changes during a reaction or process. When thermal equilibrium is reached between two objects, which statement is true? Particle collisions stop, energy transfer continues in one direction, the temperatures of both objects are equal, or one object contains more energy than the other. The answer is the temperatures of both objects are equal. There will still be energy transfer between the two objects, however, there is no net energy transfer, meaning the amount of energy that flows from object A to object B, for example, will be the same as the amount of heat energy that flows from object B to object A in the same amount of time, meaning their temperatures remain constant and are equal to each other.